Voice cloning. So voice cloning is the process of creating a synthetic voice that sounds similar to that specific person's voice. Imagine you have a favorite celebrity and you want to hear them read a book or a script. So voice cloning can enable you to do that. It includes the following steps. First, speech feature extraction. So voice cloning would start by analyzing the speech of that person whose voice you want to clone. And this analysis will extract various features from the speech such as pitch, format, frequencies and the overall shape of that voice. And these features are like the building blocks for creating a synthetic voice that sounds like an original speaker and then create a synthetic voice. So with these speech features in hand, the next step is to use various deep learning techniques to generate a synthetic voice. And these techniques use neural networks to synthesize speech waveforms or spectrograms that mimic the original speaker's voice. And the generated speech sounds like the original person, but it can be controlled and manipulated to read different text or perform different tasks. So in summary, this voice cloning is the process of creating a synthetic voice that closely resembles a specific person's voice. For example, you are reading a book in the voice of Narendra Modi ji. So by analyzing a person's speech, deep learning techniques generate a synthetic voice that can be controlled and manipulated for various applications such as virtual assistant, audiobooks and deepfake videos. Now this voice cloning working. So the methodology behind this voice cloning involves several steps which can be explained in simple terms. First, the recording and processing. So the first step is to record a large data set of speech samples from the person whose voice you want to clone. And this data set should include a variety of intonations, speech patterns and speech context. And the recordings are then pre-processed typically by converting them into numerical representations such as spectrogram. The second step is training the AI model. So the next step is to train a deep learning model on that recorded speech data. So here the model learns to identify patterns and characteristics in speech data such as intonations, pitch and speech patterns. And these models are usually recurrent neural network, long short-term memory networks or transformer based models. So once that AI model has been trained, next, it can be used to generate that synthetic speech that closely resembles the original voice. So the model takes text as an input and outputs a waveform that sounds like the cloned voice. And this process is called text-to-speech synthesis. And finally, to improve the realism of that cloned voice, this AI model can be fine-tuned using a process called adversarial training. Well, this involves training two models simultaneously, a generator and a discriminator. So this generator creates synthetic speech, while the discriminator tries to distinguish between the original and synthetic speech. The generator is then adjusted to create more realistic sounding speech. So let's explore the popular methods for voice cloning. So the popular methods for voice cloning involves analyzing a person's speech, then extract relevant features out of it and use the deep learning techniques to generate a synthetic voice that sounds like the original. So the simple methods are, first is the MEL spectrogram. This MEL spectrogram is a representation of speech that visualizes the frequency and time information. And it's a crucial component in voice cloning as it captures the essence of person's voice. So by processing the source speaker speech, MEL spectrogram can be generated which contain information about the speaker's voice. And this information can then be used to generate a synthetic voice that closely resembles the original. Then comes WaveNet. So this WaveNet is a deep neural network architecture that can generate high quality natural sounding speech. So by training this WaveNet model on a source speaker's speech, it can learn the patterns and characteristics of that speaker's voice, which enable the model to generate synthetic speech that closely mimics the source speaker's voice. And then GANs. So this GANs consist of two neural network, a generator and a discriminator. So the generator will create synthetic speech while the discriminator tries to distinguish between the synthetic speech and the source speaker's actual speech. So by training a GAN on the source speaker's speech, the generator can learn to produce synthetic speech that closely mimics the speaker's voice. And then comes Tacotron 2. Well, this is a text-to-speech system that generates natural sounding speech from text. And it consists of two components. First is the text encoder and then a Mel spectrogram predictor. Now this text encoder will process the input text, while Mel spectrogram predictor generates a representation of that desired output signal. So by training this Tacotron 2 model on a source speaker speech, it can generate synthetic speech that is closely mimicking the speaker's voice. Then comes Deep Mimic. It's an open source toolkit for voice cloning that uses a combination of WaveNet and Tacotron 2 to generate high quality natural sounding speech. So this deep mimic can clone a speaker's voice with high accuracy, making it a popular choice for applications that requires convincing synthetic voices. Then comes Wave RNN. So this Wave RNN is a voice cloning technique that requires a recurrent neural network to generate a synthetic speech. And this Wave RNN processes the source speaker's speech and learns the patterns and characteristics of speaker's voice, which enables the model to generate synthetic speech closely resembling the source speaker's voice. And these methods uses various techniques to extract the essential features of that person's voice and then generate a synthetic voice that closely resembles the original. So let's explain what are the applications of voice cloning. So this voice cloning has a wide range of applications. First is the virtual assistant. So virtual assistant like Siri of Apple, Alexa of Amazon and Google Assistant, they all use voice cloning to provide users with a more personalized experience. And these assistants recognize a user's voice, understand their commands and then respond with synthesized speech that closely resembles the user's voice, which provides a more seamless and intuitive experience for user. Then comes text-to-speech system. So this text-to-speech system are used in variety of applications such as audiobooks, language learning tools and virtual assistant. So by leveraging voice cloning technology, this text-to-speech system can generate synthetic speech which closely mimics the voice of human, which provides a more natural and engaging listening experience. Then comes video games. So in video games, voice cloning can be used to create convincing non-player characters. So by using a professional voice actor to provide that base voice, game developers can use voice cloning techniques to generate multiple variations of characters' voice, allowing for more diverse dialogues and for immersive gaming experience. Then films and animations. So here also voice cloning can be used to create voice over tracks for films and animations. And this allows actors to provide voice performances without being present on set, which saves their time and resources. So additionally, it enables the creation of characters with unique voices, even if professional actors don't voice them. Then voice-based user interface. So these are increasingly popular in smart homes, cars and other devices where voice cloning is used to create voice interfaces that closely resembles the user voice, providing a seamless and intuitive experience. And finally, deepfakes. So these deepfakes are a type of digital manipulation that uses AI to replace one person's face or voice with another. So while this technology can be misused, it also has legitimate uses in fields such as film and television. For example, actor may use deepfake technology to dub over a character's dialogue in post-production, which saves the time and money. So these are just an examples of many applications of voice cloning. So in summary, voice cloning is a technology that uses AI to create synthetic voices that resemble specific individuals. It involves recording and pre-processing speech data, training deep learning models and generating synthetic speech waveforms. And this technology has numerous applications such as virtual assistant, TTS system and video games. Thank you.